Hello and welcome to Diya Online Science Academy. Today we will solve the additional exercise of NCERT for chapter number 2. So let us begin with numerical number 2.12, which says a charge of 8 microcoulomb, 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge of -2 into 10 raised to -9 coulomb from a point P 003 centimeter to a point 040 via a point R 069 centimeter. So here some charge 8 microcoulomb is located at the origin, and due to that electric field will be generated around it. Now some other charge -2 into 10 raised to -9 is getting moved from one point to other. So work has to be done on that if we want to move that charge from one point to other point in the external electric field. So that work done equals to W equals to change in potential energy. W equals to delta U. So U2 minus U1. U is K Q0 Q1 test charge into the charge upon R. R2 final position minus K Q0 Q by R1. So K Q0 can be taken, K Q0 and Q can be taken out as common, and 1 upon R2 minus 1 upon R1 equals to 9 into 10 raised to 9. Q0 is -2 into 10 raised to -9, the charge that is getting moved, and Q is the charge due to which the electric field has been generated, into 1 upon R2. R2 is 0.04 minus 1 upon 0.03. So 9, this would be 144 into 10 raised to -3 into 100 by 4 minus 100 by 3. So 144 into 10 raised to -3, 100 can be taken out as common. So 10 raised to 2 or 100, 1 by 4 minus 1 by 3. That means 4 minus 3 by 12. Taking the LCM of 4 and 3. So we will get 144 and 12 will get cut. Here -1 will remain. So the answer would be 1.2 joule. Right? So this is the answer. Now you must have observed one thing, that these points R1 and R2 have been given in the form of those coordinates 003 and 040. So in that case R1 and R2, why they are directly been taken as 3 centimeter and 4 centimeter? Because we have to take the magnitude. So magnitude of 040 is 0 square plus 4 square plus 0 square, and it's under root. So ultimately it will be 4 squares root. That means 4. Similarly for 3 centimeter R1 003, right? So for that also it will be equals to 3 centimeter only. Second thing, the point is getting moved from one point to other via some point. So in the first theory itself of this chapter, we have seen that the work done does not depend upon the path, or the change in energy does not depend upon the path. It just depends upon the final and initial position. So you don't have to take into account the point from which, via which it has been taken. So R has just been given to confuse you. Okay, so we don't have to take that value into consideration. So this is the answer. This would be 3 minus 4. So that would be -1. So final answer will be 1 point plus 1.2 joule. 2.13. A cube of side B has a charge Q at each of its vertices. Determine the potential and the electric field due to this charge array at the center of the cube. So such arrangement has been given, a cube, and on all its vertices QQ charge has been placed, and we have to find out E and V at its center. So first of all, let us find out the electric field. here we know that electric field will be in the opposite direction. See, due to this positive Q charge and due to the diagonally opposite positive charge or this charge, the electric field will be due to this positive charge, it will be in this direction. Due to this positive charge, same magnitude but in opposite direction, the electric field will be prevailing. So both the electric fields will get nullified by each other. So likewise for all the pairs this will happen. So at the end, when you will see that there will be no electric field, so directly we will write that electric field at the center of the cube will be 0 due to diagonally opposite charges which produce electric field in opposite direction and of equal magnitude. So the first answer is 0. E center equals to 0. Now V, potential at the center. So we know that potential, electrostatic potential, V equals to KQ by R. This is the formula. Now here electric potential will be due to all the 8 charges, right? The distance for all the charge from the center is equal. So such potential, same potential will be generated 8 times due to 8 charges. So we will directly multiply this KQ by R with 8. So that will give us the total potential at the center. Now what is this R? R is the distance of each and every vertex from the center. So for that, let us look at the geometry of this configuration. See, here you can see that R is this distance, A to O. A to O is the R distance. That A to O is half of AB. So somehow if we are able to find out AB, we can make half of it and we will get the value of R. AB is what? AB is actually hypotenuse of this right angle triangle, triangle ABC, that you can see in this array, ABC, where this C will be right angle triangle, which has been shown separately over here. Okay. Now this BC is the side of that cube. So that has been given as small b. So one side we know. And the other side is this again hypotenuse of this triangle. So this side is B, this side is B. So hypotenuse will be root 2b. So AC will be root 2b. Hope you understand this. B square plus B square and its root, that means root 2b. So other side is root 2b. Now this hypotenuse will be root 2b square plus B square, root 2b square plus B square and its root. So this will be 2b square plus B square, that means 3b square and its root, that means root 3b. This is the length of side AB. Okay, AB is root 3b, but we are interested in finding out R. R is half of AB. So that will be root 3b by 2. So here we will write 8kq by root 3b by 2. So the final answer will be denominator is numerator. So 16kq by root 3b is the answer for potential at the center. 2.14. Two tiny spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb are located 30 cm apart. Find the potential and electric field. First, A, at the midpoint of the line joining the two charges, and second, B, that we will do later, at a point 10 centimeter from this midpoint in the plane normal to the line and passing through the midpoint. See, first case, A and B, at point A and B, Q1 and Q2 charges have been placed and they are been placed 30 centimeter apart. So from the midpoint their distances are 0.15 meter and 0.15 meter, that can be said, right? Now potential V equals to, V at O equals to both the charges K Q1 by R1 plus K Q2 by R2 equals to K can be taken out as common, Q1, R1 and R2 are also same, so I can just write R in place of that. R equals to R1 equals to R equals to 0.15 meter, Q1 plus Q2. So K is 9 into 10 raised to 9, R is 0.15 into 1.5 plus 2.5 into 10 raised to 6 has been taken out as common. So at the end you will get the answer for VO as 2.4 into 10 raised to 5 volt. This is the potential at the center. Now the electric field. The electric field due to positive charge will be away from it, and due to this positive charge will be away from point B. So E1 has this direction, E2 has this direction. Both are in the opposite direction at point O. So electric field at midpoint EO is actually E1 minus E2 because both are in the opposite direction. So E1 is K Q1 by R, 1 K Q2 by R2 square equals to K by R1 square, Q1 minus Q2 equals to 9 into 10 raised to 9 upon R1 square is 0.15 square, and 1.5 minus 2.5, if I take Q2 minus Q1, E2 minus E1, then I'll directly get the positive one. So that means E2 is having larger value. So 2 minus 1, 2 minus 1, 2 minus 1, and R1 and R2 can be taken as R itself. So 0.15 square. So finally your answer will be here also 2.5 minus 1.5, 4 into 10 raised to 5 Newton per Coulomb or volt per meter, E0, right? This is the solution for part A. You note down. Later we will solve part B. Now for the B part, such arrangement has been given, Q1, Q2 charge, and at some 0.1 meter distance, 10 centimeter distance from the midpoint, the electric field has to be found out, and potential. Suppose this point is P, so EP and VP we have to find out. So the electrostatic potential will be equals to addition of KQ by R, potential due to each charge. So let us first find out that. So potential at P, Vp equals to V1 plus V2, that is KQ1 by R1 plus KQ2 by R2 are this and this distances. So see 0.15 and this is 0.1. So if you apply the Pythagoras rule, then you will get the value of this, which will be almost equals to 0.18. So if you take 15 square plus 10 square and its root, then it will be almost 18 centimeter. So that has been taken. So R1 and R2 both, R1 and R2 both are equals to 0.18 centimeter. Here we will change it 0.18, or I'll take R1 dash and R2 dash are 0.18. So K is common, R1 and R2 both are same, so R1 dash only I'll write, Q1 plus Q2. K is 9 into 10 raised to 9, R1 is 0.18, Q1 and Q2 are 1.5 and 2.5, 10 raised to minus 6 microcoulomb has been taken out as common, 1.5 plus 2.5, so 2 into 10 raised to 5 volt, Vp. Okay, now E equals to electric field due to Q1 will be in such direction and electric field due to Q2 will be in such direction. So the resultant of this E1 and E2 will be in such a direction when you form a parallelogram. So the diagonal of that parallelogram will give you the resultant value. So first we have to find out E1 and E2, right? So E1 and E2, electric field due to Q1 is E1 equals to KQ1 by R1 square equals to 9 into 10 raised to 9. Q1 is 1.5 into 10 raised to minus 6 upon R1. R1 is the distance 0.18 square. There you can see 0.18 square. 0.18 square. So the answer will be 0.42 into 10 raised to 6 Newton per Coulomb or volt per meter. E1 is this. Similarly, E2. Electric field due to Q2 charge. So E2 equals to K Q2 by R2 square is 9 into 10 raised to 9 into Q2 is 2.5 into 10 raised to minus 6 and R2 is again 0.18 whole square. The answer will be 0.69 into 10 raised to 6 Newton per Coulomb. E2 is this. Now the equation for parallelogram, for finding out E, you need E1 square, E2 square and 2E1, E2 as well as cos theta. So theta also has to be found out, right? So what is the angle between these two? That means this total angle you have to find out. That angle, that means this angle. So that this is theta. So this total angle is theta and this will be theta by 2. So if we can find out theta by 2, we can find out what is the value of theta, right? So our first goal will be to find out the value of theta by 2. So for that we will take that triangle theta by 2. Well, let us give it a name P. This is charge A and this is, let's say, M. So in triangle APM, okay, triangle APM, there we have tan theta by 2. Tan theta by 2 equals to opposite upon adjacent. Opposite is 15 and adjacent is 10. You can either take both in centimeter or in meter. So tan theta, and then after when you take the, this will be 3 by 2, that means 1.5. So if you look into the table of natural tangent, the value for which you will get 1.5 there, the angle will be 56.3 degree. We are interested in finding out theta. So theta is 112.6 degree, right? So now from or resultant E, resultant electric field E, E equals to under root E1 square plus E2 square plus 2 E1 E2 cos theta. E1 square is 0.42 into 10 raised to 6 and its square plus E2. E2 is 0.69 into 10 raised to 6 and its square. Then 2 0.42 0.69 into 10 raised to 12 it will be, right? 10 raised to 6 for this, 10 raised to 6 for this, that will be 10 raised to 12 and cos 112. Theta is 112.6 degree and its root. Now what will be the value of cos 112.6? 112.6 can also be written as 90 plus that will be 10 10 22 22.6 degree. So cos theta or cos 112.6, that means you have to take cos 90 plus 22.6. Cos 90 will change the function, correct? That will become sine and the quadrant will be the second quadrant. 90 plus 22.6, that means second quadrant it will become. So in second quadrant cos is negative, so minus sine 22.6 degree. So whenever you want to take put the value of cos 112.6 degree, you should look into the table of sine and find the value of 22.6 degree. So here we will put that value. That value comes to be cos, here we will write cos 112.6, that will be minus 0.3843. Okay. So putting all those value, we will get E as 6.6 into 10 raised to 5 Newton per Coulomb. So final resultant E is this much. This is the value for V at point P and this would be the value of electric field at point P. 2.15, which says a spherical conducting shell of inner radius R1 and the outer radius R2 has a charge Q. A charge small q is placed at the center of the shell. What is the surface charge density on the inner and outer surface of the shell? So see, at the center on the surface some positive q charge has been placed on this shell, and on inside at the center positive small q charge has been placed. So we have to find out how much is the surface charge density at inner and outer surface. So due to the placement of this positive q charge, minus q charge will get induced on the surface. Okay, and due to this negative negative q charge induction, positive small q charge will get induced over here, right? So this is how induction of charge happens. But already positive plus q charge has been placed on the surface, right? So the total charge on the surface becomes q plus q. Okay. So now let us find out the surface charge density. Surface charge density, sigma equals to q, total charge, upon area on the inner surface. So on the inner surface q charge is there, upon area is 4 pi r1 square, and sigma outside on the outer surface q net by a again, that will be total charge is q plus q upon 4 pi r2 square. So these are the two surface charge densities on the inner and outer surfaces of this given arrangement. Now further it has been asked if the electric field inside a cavity with no charge is zero, even if the shell is not spherical but has any regular shape, explain. Electric field inside cavity is zero. Here we can see that if some outside any charge is there, and if I want to take inside this cavity, there is no extra work required. So that means the charge has not do any resistive, it does not have to experience any kind of resistance or any kind of attraction. So this only happens only if there is no electric field. That means no electric field will be there inside the cavity. So we will be writing the answer as the charge experiences no extra force. That means this implies no work done required, no extra work done required. That means only possible when no electric field's existence. Right? This does not depend upon the shape. Further it has been asked if the shell is not spherical but has any irregular shape. So this does not depend upon the shape of this cavity. It is independent of the shape of the cavity. So irrespective of the shape of the cavity, electric field inside that will always be zero. 2.16. Show that the normal component of electrostatic field has a discontinuity from one side of a charged surface to another, given by E2 minus E1 n cap equals to sigma by epsilon 0, where n is a unit vector normal to the surface at point and sigma is the surface charge density at the point. The direction of n cap is from side 1 to side 2, and hence show that just outside the electric field is sigma by epsilon 0 n cap. See, such arrangement has been given. A plate which is having surface charge density sigma, on one side and another side some direction n cap has been given. The direction of n cap is from 1 to 2. So obviously the opposite direction will be of minus sign, minus n cap, right? Suppose the electric field on side 1 and side 2 we want to find out, and then we will see that if it is constant, same throughout, whether E1 and E2 are same, if both of them are same, then we will say that it is continuous. But both of them are different, then we will say that it is different, right? It is not continuous one. So let us see. On side 2, for a plate which is having even surface charge density, then E will be equals to sigma by 2 epsilon 0 n cap, and on side 1 E2 E1 equals to sigma by 2 epsilon 0 minus n cap. That means minus sigma by 2 epsilon 0 n cap. Now E2 minus E1 equals to E2 minus E1 equals to, this is the difference, whichever is the electric field on the surface of the plate, that we will get by taking the difference of both the sides, electric field on both the sides, difference of them will give us the value by this thing. So sigma by 2 epsilon 0 n cap minus sigma by 2 epsilon 0 n cap, that means sigma by 2 epsilon 0 n cap plus sigma by 2 epsilon 0 n cap, that means sigma by epsilon 0 n cap. This is what they were asking us to find out. Okay, now also we have to show that inside the plate or on one side the it has been said that hence show just outside the electric field is sigma by epsilon 0 n cap. Okay, so see, inside the surface E equals to 0, that means here E1 equals to 0. So E2 minus 0 equals to sigma by 2 epsilon 0. Suppose this is inside, this is outside. So inside it will be 0. So that means E2 equals to sigma by only epsilon 0 n cap. Okay. So this is the first answer, and as both of them are different, we can say that it is not continuous one. Next, it has been said that show that tangential component of the electrostatic field is continuous from one side of a charged surface to another. See, for that we will be taking a Gaussian surface, okay, and over that we will be taking a loop which has been shown by the dotted lines, and over that how much will be the total work done or integration, that we will be finding out. And over that closed loop, the line integration of electric field will be 0. So on the given loop, E dl plus E2 dl2 and its integration, that will be equals to 0. Here we just have to take these two only, because for this side and this side the E and dl both are perpendicular to each other, so that will get cancelled out. Here one thing will be positive, that means cos 0, and other will be cos 180. So E1 dl, or I'll just write L, d1 into L cos 0 plus E2 into L cos 180 degree equals to 0. That means E1L cos 0 is 1, this is minus 1, so minus E2L equals to 0. So E1L equals to E2L, that can also be said. So E1 equals to E2. This is how it gets proved, that the tangential component of electric field is continuous from one side of the charged surface to another. One side of the charged surface to the another, it is continuous. Same आया, मतलब कि वो continuous है. 2.17, a long charged cylinder of linear charge density lambda is surrounded by a hollow coaxial conducting cylinder. What is the electric field in the space between the two cylinders? So electric field has to be found out over, let's say, this dotted cylindrical surface, right, which is having radius equals to small r. So electric field, this can be considered as a Gaussian surface. So for the Gaussian cylindrical surface, there we can apply the formula for Gauss's law can be applied over that. So E dot A equals to Q by A. One thing is Q by epsilon 0, Here Q by epsilon 0 we will be taking. Q by epsilon 0. So E into A is what? Area, surface area of that Gaussian surface. So 2 pi RL. As it is a cylindrical one, so for cylinder the curved surface is equals to 2 pi RL equals to Q. Here how much charge is there, that has not been given, but in place of that linear charge density has been given. So linear charge density equals to Q by L. That means Q equals to lambda L. So lambda into L by epsilon 0. L will get cancelled out and E equals to lambda by 2 pi epsilon 0 into R. So that is the answer. 2.18. In a hydrogen atom, the electron and proton are bound at a distance of about 0.53 angstrom. Estimate the potential energy of the system in electron volt, taking the zero of the potential at infinite separation of the electron from proton. Right? So at infinite separation, that means distance between electron and proton, when it becomes infinite, the potential energy becomes zero. So with respect to that, at this distance, at 0.53 angstrom, you have to find out the potential energy. So A equals to potential energy U equals to, it is actually U2 minus U1, right? So at infinite, this U1 is at distance infinite, that has already been given as 0, right? So whatever will be U2 is at distance 0.53 angstrom only. So we will just be writing U2, and U2 is K Q1 Q2 by R. So K is 9 into 10 raised to 9, Q1 is 1.6 into 10 raised to minus 19, again 1.6 into 10 raised to minus 19 for proton and for electron, divided by, or you can write minus over here and plus over here, Q1 and Q2, divided by 0.53 into 10 raised to minus 10. Moreover, if you want to find out this energy into electron volt, you will be dividing this by 1.6 into 10 raised to minus 19. So the final answer would be negative 27.2 electron volt. In joule, it will be around 43 point something. It will be 43.4 into 10 raised to minus 19 joule, and when you divide it by this, you will get 27.2 electron volt. Okay, so this is the first answer. Second thing is kinetic energy. What is the minimum work required to free the electron, given that its kinetic energy in the orbit is half the magnitude of potential energy obtained in A? Kinetic energy is half the magnitude. Magnitude of it is, that means if we are getting negative over here, so if I want to take the magnitude of it, I'll also have to take minus over here, or I'll simply put the magnitude mode around this, mode of U, and half of it will be the kinetic energy that we have to find out. And then after, we have to find out how much is the work done. So work done equals to delta K equals to, one kind of kinetic energy will be 0, so K final minus K initial equals to 0 minus 1 by 2 of U. U is 27.2, right? So that will be 13.6 electron volt. So the work done that is required is 13.6 electron volt. Further, it has been said, what are the answers in A and B and above, A and B above, if the zero of potential energy is taken at 1.06 angstrom separation. Initially, it had been said that the zero potential should be taken when the separation between them is infinite. There we had written u2 minus u1, then one part will be 0, that we had written, right? But here we will have to take the difference of both the potential energies, difference of potentials at this distance and at this distance. So u equals to u1 minus u2 equals to k q1 q2 by r1 minus 1 upon r2 equals to k q1 q2 by 1 upon r1 minus 1 upon r2 equals to 9 into 10 raised to 9 into minus 1.6 into 10 raised to minus 19. I'll take this minus over here and will make the square of this q1 and q2, and into bracket 1 upon r1 is 0.53 angstrom, 1 upon 0.53, 9 into 10 raised to 9 into 1.6 into 10 raised to minus 19 and its square, minus sign over here, 1 upon 0.53 minus 1 upon 1.06, and the conversion factor 10 raised to minus 10 is taken over here as common. So the final answer would be 13.6 electron volt. That is the answer for potential. Now for B also we have to find out. So for B it will be the kinetic energy will be, now here it has not been said that the kinetic energy will be half of it. So the kinetic energy, because at infinity the total energy will be 0, so the kinetic energy will be equals to 13.6 electron volt. Okay, so these are the answers. Question number 2.19, which says if one of the two electrons of H2 molecule is removed, we get a hydrogen molecule ion H2 plus in the ground state of an H2 plus of the two protons are separated by roughly 1.5 angstrom and the electron is roughly 1 angstrom from each proton. Determine the potential energy of the system. Specify your choice of 0 of the potential energy. So here the arrangement has been given like this, that an electron has been removed from the atom in such a manner that it remains at 1 angstrom from each of these charges, and distance between the two charges, that means these two forms a H2 plus ion, distance between them is 1.5 angstrom. Okay, so here the distance is r12, r13 and r23 has been represented over here. Q1 is minus Q, that is electron. So electron is having Q1 will be treated as minus 1.6 into 10 raised to minus 19, and these two represents proton. So the value of Q2 and Q3 is 1.6 into 10 raised to minus 19. Q1 represents electron, so minus 1.6 into 10 raised to minus 19, and Q2 and Q3 are 1.6 into 10 raised to minus 19 Coulomb. So the total energy or total potential energy for the given configuration U equals to U12, U23, U13, K Q1 Q2 by R12 plus K Q2 Q3 by R23 and K Q1 Q3 by R13. K can be taken out as common. Q1, as it is said, it is 1.6 into 10 raised to minus 19. Q2 is also 1.6 into 10 raised to minus 19. Only one of them is negative. So taking the negative sign out and making the square of 1.6 into 10 raised to minus 19. We will also write the value of K, that is 9 into 10 raised to 9. R12 is 1 angstrom, 1 into 10 raised to minus 10 plus Q2 and Q3. Q2 and Q3 are 1.6 into 10 raised to minus 19 and square of it upon R23. So 1.5 into 10 raised to minus 10 plus Q1, Q3. Again one of them is negative and the value is same. So taking square of 1.6 into 10 raised to minus 19, R13 is again 1 angstrom. So 1 into 10 raised to minus 10. Okay. So when you calculate, you will get some answer in joule. Then after, if you want to get the value in electron volt, you should divide this by 1.6 into 10 raised to minus 19 if you want to get the answer in electron volt. So the final answer would be 19.2 electron volt, that too in minus. Here we are also been asked that specify your choice of zero of potential energy. So the zero of potential energy is considered as at infinity the potential energy of such system is zero. So we will be writing it like this, that at infinity the potential energy is considered as zero. Question number 2.20, which says two charge conducting spheres of radii A and B are connected to each other by a wire. What is the ratio of electric fields at the surface of the two spheres? So E1 by E2 we have to find out. And here the spheres have been connected by a wire. So as the spheres are connected by a wire, they are at the same potential. That means V1 equals to V2 equals to V, we can say. Now C equals to Q by V, therefore Q equals to C by V. Now here C will remain variable and V will be constant, so Q will only depend upon C. So I can take Q1 by Q2 equals to C1 by C2. Why do we do this? Why are we taking the ratio of charges? Because we want to find out E1 and E2, and E1 by E2 gives me K Q1 by A square by K Q2 by B square. K cut, that is equals to Q1 by Q2 into B square by A square, right? Now as these are spheres, we know that C equals to 4 pi epsilon 0 r. That means C is proportional to r radius. So here we can write Q1 by Q2. From 1 and 2 we can write from 1 and 2 Q1 by Q2 equals to A by B. This can be utilized over there. Q1 by Q2 is A upon B into B square by A square, because from 3 equals to B by A. So this is the ratio of electric fields. that is inversely proportionate to the radius of both the spheres. Now further it has been asked, use the result obtained to explain why the charge density on the sharp and pointed ends of the conductor is higher than on its flatter portion. So here you can see that electric field is inversely proportionate to the radius. So as the radius is larger, as the distance is larger, or the surface, the flat surface is having more curved or more exposed surface, it will be having less electric field. And as the distance lessens, that means it becomes sharper, then the electric field will become somewhat sharp. Electric field will become somewhat stronger. Okay, so that is the conclusion. So as E is proportional to 1 upon R, the electric field becomes stronger near sharp edges. Now electric field equals to sigma by epsilon 0 for some surface. So as E is proportional to sigma, or sigma is proportional to E, for sigma also we can say from 4 and 5, we can say sigma is proportional to, or sigma 1 by sigma 2 is also equals to B by A. So this stands true for the surface charge density also. Question number 2.21. Two charges minus q and plus q are located at points 0, 0 minus A and 0, 0 A respectively. What is the electrostatic potential at the points 0, 0, 0 and xy 0? So here on z axis, let us consider that this axis is z axis, and on that at some point which are at minus A and plus A distances, two charges plus q and minus q have been placed, and we have to find out the electric field, electrostatic potential at 0, 0 z and at point xyz, that means on the bisector equator. So first let us find out the electrostatic potential at this point. So electrostatic potential at P, V equals to V plus plus V minus equals to K Q minus R minus plus K Q plus charge upon R plus charge. K Q minus is this distance. So this is actually 0 plus Z. Z, and this distance is A. So K Q upon Z plus A, and K Q, positive charge is at distance. See, this is Z, this distance is A, and we have to find out this distance, that should be written as R plus. So R plus distance is actually Z minus A, Z minus A. So KQ upon Z minus A minus 1 upon Z plus A equals to KQ by Z plus A minus Z plus A upon LCM is Z square plus A square. This is square. KQ, ZZ gets cancelled out, 2A upon Z square minus, it will be Z square minus A square. So we can also write 2AQ is P. So Kp upon Z square minus A square. This is the potential at point 0, 0, Z. Also at xy 0. So as I have said earlier, point xy0 is at or is on the equator of dipole. V on xy0 will be equals to 0 because it will be at the equal distance from both the charges and that will get nullified. Okay. Now the next point is B. Obtain the dependence of potential on the distance r from a point from the origin when r by a is far greater than 1. Okay. So here we have actually obtained the absolute dependence of potential on the distance. So here some special case should be taken. This is the answer for A. Now for B, let r far greater than A. R, that means over here we have taken it as Z. So Z is far greater than A. So in comparison of Z, A square will become very small. So that can be neglected from denominator. So the answer will now be only Kp upon Z square. That means V depends upon 1 upon Z square or 1 upon R square. Okay. So it is inversely proportional. Potential will be inversely proportional to the square of the distance. Now point C, question C. How much work is done in moving a small test charge from the point 500 to minus 700 along the x-axis? Where is it? 500 and minus 700 and minus 700 are the points on x-axis. So we have already said that as in the plane xy plane or on the x-axis or on the y-axis, the distance will remain same. माइनस क्यू से और प्लस क्यू से एक्स एक्सिस के ऊपर जो भी डिस्टेंस होगा वो सारे डिस्टेंस सेम रहने वाले हैं. सपोज आई एम टेकिंग दिस एज एक्स जेड एक्सिस और इसको मैंने एक्स एक्सिस ले लिया, तो एक्स एक्सिस पे चाहे कोई भी दो पॉइंट्स ले लिए. लेट्स से दिस इज माइनस 700 and this is 500. So this distance is same, this and this distance will also be same. So no potential over here, no potential over here. Y plane will be like this. So on this plane, on any point if it moves, the charge is being moved on any point on xy plane, the potential will not get changed, where V equals to constant. Delta V will be 0 and work done equals to Q into delta V. But as delta V is 0, work done will also be equals to 0. So no work is required to be done in such case. Question number 2.22, which says figure shows charge array known as quadruple. For a point on the axis of the quadruple, obtain the dependence of potential at r for r less than a, r by a is far greater than 1 and contrast your results with that due to an electric dipole and an electric monopole. So for such a quadruple, we have to find out how much is the electrostatic potential at point P, which is at distance r. Okay, so total potential, electrostatic potential at P, V equals to V plus V due to negative charge plus V due to one more negative charge. Actually these two minus Q are overlapping each other, minus Q and minus Q. So directly we can also write minus 2Q. That forms a quadruple, and V plus. Now this first charge, for that KQ by R, distance of that charge from that point. So that distance would be R plus A, R plus A, minus that would be K minus Q by R. One more time, K minus Q by R. And for positive charge it will be this distance only. So total distance R minus this A distance. So KQ by R minus A. So now we have KQ as common factor, KQ by R plus A. These two are minus 2, minus 1, minus 1. So minus 2 upon R plus 1 upon R minus A. Taking LCM of this, LCM will be R into R plus A into R minus A. R plus A, R minus A becomes R square minus A square. Now this should be multiplied with these two. So R into R minus A minus 2. This term should be multiplied by these two. These two, that means R square minus A square. R square minus A square. And this one with these two. R plus A equals to KQ upon R square minus AR minus 2R square plus 2A square plus R square plus AR upon R into R square minus A square. Now AR will get cancelled out. Minus 2R square and R square will also get cancelled out. So the remaining term will be 2A square only. So KQ by 2A square upon R square minus A square, and this 2A square into Q should be called as quadruple moment. As 2AQ is dipole moment, 2A square Q will become quadruple moment. So this is the first answer. Further, we have to compare, or we have to contrast our answer with the monopole and the dipole. So here if we take R far greater than A, or R by A greater than 1, then we can neglect this A square with in comparison to R square. So V will be KQ or 2A square Q into K by only R cube. That means for quadruple, V is proportional to 1 upon R cube, whereas for dipole it was proportional to 1 upon R square, and for monopole, that means for single charge, V is proportional to 1 upon R. So these are the answers. Question number 2.23, which says an electrical technician requires a capacitor of 2 microfarad in a circuit across a potential difference of 1 kilovolt. A large number of 1 microfarad capacitors are available to him. each of which can withstand a potential difference of not more than 400 volt. Suggest a possible arrangement that requires the minimum number of capacitors. So n number of capacitors are available with the technician, and he has to arrange those capacitors in such a manner that he will require the minimum amount of capacitors, and from the combination, from series and parallel combination of those capacitors, ultimately he will get the equivalent capacitance as 2 microfarad. Okay, and each and every individual capacitor has the limitation for bearing the potential, that is given as 400 volt, right? So here we will write that suppose we have like this, some capacitors are arranged in series, right? I don't know how many will be arranged in series, but suppose only this is the connection and 1000 volt, that means 1 kilovolt is supplied across this connection, then this 1000 volt will get distributed among the number of capacitors, right? This two ends, this two ends, and between these two ends the addition of V1, V2 and V3 will be equals to 1000, and individually V1, individually V2, individually V3 or individually V4, I don't know how many will be there in the series. So individual potential across the two plates of capacitor should not exceed 400 volt. So we will write that suppose n capacitors are connected in series, therefore 1000 number of capacitors that will be required is equals to n equals to 1000 divided by 400 number of capacitors, because as I said this 1000 is going to be divided among these, so it is having limit equals to 400, that's why we are dividing this 1000 by 400. So n will come as 2.5, right? So this is the number of capacitors that is required in series, but you cannot take 2.5, 2.5 capacitor. You can either have 2 capacitors or 3 capacitors. Now what should we take? Should we take 2 or 3? Rounding up or rounding down? So let us take let us say we are taking 2 capacitors. So 1000 volt will be divided into 2 capacitors are there. So each and every capacitor will have potential difference of 500 volt. 1000 is getting divided into only 2. So 500 volt will be there across its 2 plates, but that is beyond its limit. So we cannot take 2. We cannot round down. We have to round up, right? So we will be writing n is equals to 3. So if it is 3, then 1000 into 3 parts, that is 333.33, 333.33 and 333.33. So it is less than 400. So that's how n capacitors, that means 3 capacitors should be connected in series. Now how about parallel? Such 3 capacitors will be there and some rows must be made. ये जो डॉटेड लाइन कर रही हूँ इसका मतलब है यहाँ पर कितनी ऐसी रोज होगी दैट आई डोंट नो. यहाँ पर पहले डॉटेड थी, उसको फुल लाइन बना दी, मतलब अब मुझे पता है ओनली 3 कैपेसिटर्स विल बी देयर इन सीरीज. सो नाउ हाउ मेनी सच रोज विल बी देयर दैट वी डोंट नो, but we know that capacitor of each and every individual capacitor is 1 microfarad, 1 microfarad, 1 microfarad. So in a row equivalent capacitance is equals to 1 upon C equivalent series equals to 1 divided by 1 upon C1, 1 upon C2 and 1 upon C3. So this will be 3 by 1. That means C equivalent series equals to 1 upon 3. So each row is giving me 1 upon 3 microfarad, 1 upon 3 microfarad, 1 upon 3 microfarad. Now from that you have to make a combination which gives me 2 microfarad. So now to obtain capacitance of 2 microfarad, let's say this is equivalent, in the parallel connection it will be getting multiplied, m into 1 by 3. What is m? M equals to number of rows. We know that equivalent capacitance in parallel is equals to addition of the capacitors. So let's say m rows are there, so m times it will get multiplied, right? 1 by 3 plus 1 by 3. So 2 into 1 by 3 or 1 by 3 plus 1 by 3 plus 1 by 3, that means 3 into 1 by 3. So here by this combination you should get 2 microfarad capacitance. So it says m equals to 6. So in series you should connect 3 capacitors and you should make 6 such rows. अब ये जो यहाँ पर है ऐसी 6 रोज बन जानी चाहिए, 1 then 2 then 3 then 4 5th and 6th, and across that 1000 volt 1 kilovolt is connected. So this is the required arrangement. Likewise it will be connected. You should complete this row by yourself. So this is how the arrangement would look like. There is one more row. So this is how the connection would look like. Question number 2.24, which says, what is the area of the plates of 2 farad parallel plate capacitor given that the separation between the plates is 0.5 centimeter? So C is 2 farad and D equals to 0.5 centimeter, that means 0.5 into 10 raised to minus 2 meter. So for parallel plate capacitor we have to find out the area of the plate. For parallel plate capacitor, C equals to epsilon 0 A upon D. So A equals to C into D by epsilon 0 equals to 2 into 0.5 into 10 raised to minus 2 by 8.85 into 10 raised to minus 12. So the answer will be 1130 into 10 raised to 6 meter square or 1130 kilometer square. So this big plate would be required if you want to have the capacitance equals to 2 farad. Question number 2.25, which says obtain the equivalent capacitance of the network in the figure shown. For a 300 volt supply, determine the charge and voltage across each capacitor. So first we will find out the equivalent capacitance. Here you can see that the circuit has been given like this. This can be simplified further like this. The C2 and C3 are in series connection with each other. So that will give us equivalent capacitance as C23. Now supply is over here, that means from here there are 2 branches. अब जहाँ से भी branches पड़ती है उसके across जो भी apparatus आते हैं वो parallel connection में हो जाते हैं. So here C1 and C23 are in parallel connection with each other. So C1 and C23. तो उनका फिर हम लोग इक्विवेलेंट कैपेसिटेंस निकालेंगे. Then after the equivalent circuit would look like this. So C123, that is equivalent of C1, C2 and C3 is over here, and C4 are in series connection with each other, no branching. That means C123 and C4 are in parallel, and finally you will get C equivalent. So we will go in this manner for calculation also. This is C4 and this is C equivalent. So now as C2 and C3 are in series connection, so C equivalent for series या तो हम लिखेंगे C23 equals to C2 C3 by C2 plus C3. 1 upon C2 plus 1 upon C3 will give us 1 upon C equivalent. So this is the final answer for C equivalent. Now C2 is 200 into 200 by 200 plus 200. So you will get the answer as 100 picofarad. Okay. Now C23 and C1 are in parallel connection. C23 and C1 are in parallel connection. Therefore C123 equals to C1 plus C23. C1 is equals to 100. C23 is equals to also 100. So that will give you 200 picofarad. Now C123 and C4 are in series connection. So C123 and C4 are in series connection. Therefore, that will give us the final equivalent capacitance. So I won't write C1234. That is directly C equivalent. For series connection, it will be 200 C123. 200 into 100 by 200 plus 100. So that will be 200 by 3 picofarad. So this is the equivalent capacitance. One answer we have obtained. Now second question is for 300 volt, determine the charge. After charge we can find out the voltage. So how much would be the charge? So for that we will be starting with this final circuit. 300 volt is being supplied to this much capacitance. So we know the value of V and C. So we can find out how much is the total charge that is being supplied. Total charge supplied equals to C equals to Q by V. So Q equals to C into V. Here Q is total, so C should be equivalent one for this circuit. So C equivalent is 200 by 3 picofarad. So 200 by 3 into 10 raised to minus 12, and voltage is 300. So the answer would be 200 into 10 raised to 10. So that is Q. Okay. 0 0 200 and 3 will get cut over here, 100 and 10 raised to 2, 10 raised to minus 12, so 10 raised to minus 10 Coulomb. So this is the total charge that is being supplied. Now that will be given to C4. So this Q is actually equals to Q4 also. Therefore Q4 equals to 200 into 10 raised to minus 10 Coulomb, or 2 into 10 raised to minus 8 Coulomb. Now C123, that means Q123 is also in series. So C123 will also get the charge as 200 into 10 raised to minus 10 Coulomb. Now C123 is further made up of C23 and C1. So whatever charge is drawn by C123, that is actually the total charge of C1 and C23. बराबर ना, यहाँ से जो चार्ज आएगा C, अब इधर से चार्ज यहाँ पर आया तो ये 200 या 2 इंटू 10⁻⁸ आया यहाँ पर, और इन दोनों में वो सेपरेट हो जाएगा. अब कितना कितना किसको मिलेगा, 2 इंटू 10⁻⁸ जो है वो किसको कितना मिलेगा, तो C1 की वैल्यू कितनी 100, C23 की वैल्यू कितनी, वो भी है 100. तो इक्वल कैपेसिटेंस है दोनों वेज में इक्वल कैपेसिटेंस, तो जो चार्ज है वो भी इक्वली डिवाइड होगा. हियर C1 equals to C23, therefore Q1 is equals to Q23 and that is equals to Q123 by 2, क्योंकि ये ऐड होके उधर बन रहा है यहाँ पर इस जंक्शन पे. बराबर, तो Q1 equals to Q23 equals to 2 इंटू 10⁻⁸ या तो 200 इंटू 10⁻⁻10 डिवाइडेड बाई 2, तो ये 1 इंटू 10⁻⁸ कूलम. Q1 की वैल्यू यहाँ से हमें मिली. अब Q23 जो है वो एक्चुअली किससे बना, C23 किससे बना, C2 एंड C3 से. तो Q23 इस ब्रांच में जाएगा, वो इधर ही जा रहा है ऐसे हम समझ सकते हैं. तो मतलब C2 और C3 दोनों को सीरीज में है, इसलिए इतना ही चार्ज मिलेगा. एज C2 एंड C3 आर इन सीरीज कनेक्शन, Q2 equals to Q3 and that will be equals to this Q23 only. बराबर, पैरेलल में है तो डिवाइड करना पड़ेगा जितनी भी ब्रांचेज है उससे. यहाँ पर यह सीरीज में है इसलिए उतना ही मिलेगा, सीरीज में चार्ज चेंज नहीं होता. तो वो वैल्यू कितनी, Q2 equals to 1 into 10⁻⁸ Coulomb and Q3 is also equals to 1 into 10⁻⁸ Coulomb. Now एक और क्वेश्चन पूछा है जिसमें हमें फाइंड करना है पोटेंशियल अक्रॉस ईच कैपेसिटर. तो पोटेंशियल V1 इक्वल्स टू C इक्वल्स टू Q बाई V, तो V इक्वल्स टू Q बाई C, Q1 बाई C1 इक्वल्स टू Q1 की वैल्यू कितनी, 1 इंटू 10⁻⁸ बाई C1 इज 100 इंटू 10⁻12. So that will be equals to 100 volt. V2 equals to Q2 by C2. Q2 equals to 1 into 10⁻⁸ upon C2. C2 is 200 into 10⁻12. So that will be 50 volt. V1 is 100. V2 is 50. V3 equals to Q3 by C3 equals to Q3. Q3 is again 1 into 10⁻⁸ and C3 is again 200 picofarad. So that will be equals to again 50 volt. V3 and V4. V4 equals to similarly Q4 by C4. Q4 equals to 200 into 10⁻⁻, 200 or 2 into 10⁻⁸. C4 is 100 into 10⁻12 equals to 200 volt. V4. So these are all the answers. Question number 2.26, which says the plates of parallel plate capacitor have an area of 90 centimeter square each and 90 centimeter square each and are separated by 2.5 mm. The capacitor is charged by connecting it to 400 volt supply. how much electrostatic energy is stored by the capacitor. So first answer, for the first answer, the energy stored in a parallel plate capacitor equals to U equals to half C V square equals to half C for parallel plate capacitor equals to epsilon 0 A upon D into V square. So 1 by 2 into epsilon 0 is 8.85 into 10 raised to minus 12. A is 90 centimeter square. So 90 into 10 raised to minus 4 meter square. 90 into 10 raised to minus 4 meter square divided by D, 2.5 into 10 raised to minus 3, converting it into meter, into V square. So 400 and its square. So the answer would be 2.55 into 10 raised to minus 6 joule or 2.55 microjoule. Now the next question, which says view this energy stored in electrostatic field between the plates and obtain the energy per unit volume U. Hence arrive at a relation between U and magnitude of electric field E between the plates. So energy density we have to find out. So energy density rho E equals to U upon volume. Volume is area into distance between two plates. So rho E equals to U is what? Half C V square upon A D. Half for parallel plate capacitor it will be epsilon 0 A upon D into V square upon A into D. So here AA will get cancelled out and epsilon 0 then V square upon D square will remain. Now E V equals to ED equals to V upon D equals to E square. So I can write half epsilon 0 into E square. Also if we want to find out the value of this rho E, then putting the value of U into this formula, 2.55 into 10 raised to minus 6 upon A. Area is 90 into 10 raised to minus 4 into D, 2.5 into 10 raised to minus 3. So the answer would be 0.113 joule per meter cube. Question number 2.27, which says a 4 microfarad capacitor is charged via 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 2 microfarad capacitor. How much electrostatic distance of the first capacitor is lost in the form of heat and electromagnetic radiation? So here C1, C2 have been given. This is charged one, this is uncharged, and it is connected with this, and 200 volt supply was given to this C1. V2 is considered at zero potential. We have to find out in this process how much is the energy that is lost. So there is a simple formula for this: energy lost or energy dissipated, delta U equals to Ui minus Uf equals to C1 C2 by 2 C1 plus C2 into V1 minus V2 whole square. C1 C2 is 4 into 10 raised to minus 6 into 2 into 10 raised to minus 6 upon 2 into 4 plus 2, common is 10 raised to minus 6. V1 is at 200 volt and V2 is at 0 volt. So the answer will be 2.667 into 10 raised to minus 2 joule. This much energy will be lost in the said process. Question number 2.28, which says show that the force on each plate of a parallel plate capacitor has a magnitude equals to QE by 2, where Q is charge on the capacitor and E is the magnitude of electric field between the plates. Explain the origin of the factor 1 by 2. So this is what we want to prove. Now we will be starting with a formula where F appears. So we will take like this: work equals to energy. Energy equals to energy density into volume. Rho E into this. We know that rho E equals to U by AD. So U equals to rho E into AD. So now work done equals to force into displacement. Energy density is rho E into AD, or A into, here delta x has been taken. So delta x will get cancelled out. So now we have F only. In place of rho E we can write 1 by 2 epsilon 0 E square, and A is there. Now from this two E squares, 1E will be written as sigma by epsilon 0, electric field for parallel plate. So sigma by epsilon 0 and E into A, because E equals to sigma by epsilon 0. Epsilon 0 will get cancelled out, and the things that remain is sigma into EA. Now in place of sigma we can write Q by A. It is the surface charge density. Sigma equals to Q by A. AA will get cancelled out. So half Q into E. This is what we wanted to prove. Now further it has been asked what is the reason of origin of this 1 by 2 factor. So because we know that F E equals to F by Q, right? Why does this? So F should be equals to E into Q or Q into E. Why does this 1 by 2 appear? So the reason is inside the plate the electric field will be 0 and outside it will be E. So average electric field will be E and 0, E plus 0 by 2, right? So that is why this 1 by 2 factor appears. As outside electric field is E and inside electric field is 0, the average electric field equals to E plus 0 by 2 equals to E by 2. Therefore 1 by 2 factor appears. Question number 2.30, which says a spherical capacitor has an inner sphere of radius 12 cm and outer sphere of radius 13 cm. The outer sphere is earth and inner sphere is given a charge of 2.5 microcoulomb. The space between the concentric spheres is filled with a liquid of dielectric constant 32. First thing that we have to find out is determine the capacitance of the capacitor. So here the arrangement is like this. Two concentric spheres have been given. So the capacitance of such a sphere can be given by the formula that has been derived in question number 2.29, which we have already covered in one of the lecture or theoretical lectures, right? So for concentric spheres, capacitance C equals to 4 pi epsilon 0 r1 r2 upon r2 minus r1. This would be the special formula for concentric spheres. Now here the space between two spheres is filled up by some dielectric material. So we cannot take epsilon over here. Instead of that we should take epsilon, right? So now it will be 4 pi epsilon 0 into k. Epsilon equals to epsilon 0 into k. R1 R2 by R2 minus R1. Substituting the values 4 pi, or further we can also write this as capital K R1 R2 by 4 pi epsilon 0 is 1 upon k. So small k into R2 minus R1 equals to 32 into R1 is 12 into 10 raised to minus 2 into R2 is 13 into 10 raised to minus 2 by k is 9 into 10 raised to 9. R2 is 13 minus 12 into 10 raised to minus 2 taken out as common. So the answer will be 5.5 into 10 raised to 9 farad or 5.5 nanofarad capacitance. So this is the answer for question A. Then second one, B. What is the potential of the inner sphere? So the potential of inner sphere C equals to Q by V. So V equals to Q by C. Q by C. C we know now. How much is the capacitance? 5.5 into 10 raised to minus 9. Q is 2.5 into 10 raised to minus 6. So voltage will be 450 volt. Right? Now third question. Third question is compare the capacitance of this capacitor with that of an isolated sphere of radius 12 centimeter. Only one capacitor is made up by only one sphere. So for that, it is not concentric. Two spheres are not making a capacitor. Only one sphere is making. For that, the formula for capacitance, formula for isolated spherical capacitor is C equals to capital R upon K. Radius of that 12 centimeter capacitor. So here I will be writing R1 by K. R1 is 12 into 10 raised to minus 2. K is 9 into 10 raised to 9. So that will be 4 by 3. So 1.3 into 10 raised to minus 11 farad capacitance. So these are the answers. Question number 2.31, which says, answer carefully. Two large conducting spheres carrying charges Q1, Q2 are brought closer to each other. So for that also can we apply the formula which is already derived by Coulomb, that is stated in Coulomb's law. So what happens when two spheres are brought together? Induction will happen, right? When two spheres or charged spheres brought together, induction will happen, charge induction will happen. Thus charges or charge on sphere कैन नॉट बी कंसीडर्ड as concentrated at center or point charge. As a point charge we cannot consider it. So there's a limitation of Coulomb's law that it can only be applied if the charges are stationary and if it is considered as a point charge. Here it cannot be considered as a point charge. Therefore Coulomb's law is no longer applicable. Second one, that if Coulomb's law involved 1 upon r cube depends instead of 1 upon r square, would Gauss's law will be true? Then the answer will be no. For Coulomb's law, the experiment has been made in such a manner that वो तभी एप्लीकेबल होता है, लॉ जो है वो लॉ के अंदर 1 अपॉन आर स्क्वायर ही है और उसके बाद फिर गॉसेस लॉ डिराइव होने के लिए उसी को बेसिस लेके किया है. सो इफ इट इज 1 अपॉन आर क्यूब देन गॉसेस लॉ जो अभी है वैसा ये ट्रू नहीं होता. राइट, सो बी के अंदर आंसर आएगा नो. देन सी जो है वो a small test charge is released at rest at a point in an electrostatic field configuration. Will it travel along the field line passing through that point? So here also the answer would be no. The reason is field lines represent the direction of force or acceleration and not the velocity. Field lines direction represent the direction of force or acceleration and not the velocity. So but if the lines are parallel or straight line, this is true only if, that means the field line will represent the direction of velocity will only be true only when lines are straight. Then D, that says what is the work done by the field of nucleus in a complete circular orbit of the electron, and what if the orbit is elliptical. So here the electron is revolving around the nucleus and it has started from one point and it comes back to that point only. So how much is the displacement? Zero displacement. It has not got displaced after one complete revolution. So for work to be done, there has to be some distinct situations in initial and final position. Here it doesn't happen, so no work is done. So answer will be 0, as the reason will be as the initial and final positions are same. Now if it is elliptical, then also if it is elliptical, that is also a closed one. It is starting from this point and comes back to the same point. So there also no work done will be there. So if it is elliptical, W is again 0. Right, so it doesn't depend upon the path. Only if it is any closed shape, अगर कोई भी क्लोज्ड कर्व वो फॉलो करके वापस आ जाता है तो उस केस में वर्क डन इलेक्ट्रॉन का जो है वो 0 हो जाएगा इलेक्ट्रॉन के ऊपर का. देन E, we know that electric field is discontinuous across the surface of a charged conductor. Is the electric potential also discontinuous there? So the difference between electric field and electric potential is one is having a direction and other is not having. That means one is vector quantity and the other is scalar quantity. So potential is a continuous one. Here electric field is a vector quantity. तो कोई कोई जगह पर क्या होगा, डायरेक्शन एक इस तरफ तो कहीं पर वो जीरो हो जाएगा, कहीं पर आपको ई मिल रहा है फिर जीरो मिलेगा फिर कुछ और क्वांटिटी मिलेगी. सो इट बिकम्स डिसकंटिन्यूअस, बट देयरफॉर इट कैन बी discontinuous, but electrostatic potential is a scalar quantity और एक डिस्टेंस पे जितना मिला वो वहां पर उतना ही होगा, वो सारे डिस्टेंसेस पे उतने सारे डिस्टेंसेस पे. सपोज कि ये पॉजिटिव क्यू चार्ज लिया उससे आर रेडियस पे, तो यहाँ पर सारे जगह पर पोटेंशियल जो है वो सेम ही आएगा, कहीं पर जीरो नहीं होगा, फिर और नए डिस्टेंस पे कुछ नया होगा उसकी वैल्यू. तो देयरफॉर इट विल नॉट बी डिसकंटिन्यूअस. Or it will be continuous. A, B, C, D, E, and now the F question, which says what meaning would you give to the capacitance of a single conductor? अगर सिंगल कंडक्टर लेके आप कैपेसिटेंस जो है वो कैपेसिटर फॉर्म कर रहे हो तो उसमें आपको पोटेंशियल डिफरेंस उसके अक्रॉस कितना होगा. जो कैपेसिटर है उसकी दो प्लेट्स ले लो या कोई भी दो पॉइंट्स के दो टर्मिनल्स के अक्रॉस, हाउ मच विल बी द पोटेंशियल. तो उसके लिए क्या करना है, पोटेंशियल डिफरेंस होना चाहिए. सो द अदर कैपेसिटर इज कंसिडर्ड एज इनफाइनाइट और इनफाइनाइट पोटेंशियल. द अदर वन और अदर कंडक्टर is considered at infinity. Then next, G, guess a possible reason why the water has much greater dielectric constant than say mica. Water has dielectric constant approximately 80 and mica has 6. So what is the reason that these two are having such a big difference in dielectric constant? So water has very strong and permanent dipole moment. The molecules or the electric dipole moment between the molecules of water is permanent and of high value as compared to mica. So that is the reason. Question number 2.32. A cylindrical capacitor has two coaxial cylinders of length 15 cm and radii 1.5 cm and 1.4 cm. The outer cylinder is earth and the inner cylinder is given a charge of 3.5 microcoulomb. Determine the capacitance of the system and the potential of the inner cylinder. Neglect the effects, that is bending of filled lines at the ends. So here the concentric cylinder has been given and for that we have to find out the capacitance. So for concentric cylinder, concentric cylindrical capacitor, C equals to 2 pi epsilon 0 L by ln R2 by R1. So 2 into pi 3.14 epsilon 0 8.85 into 10 raised to minus 12 L 0.15 meter divided by ln is 2.303 log R2 is 1.4 centimeter by 1.5. I haven't converted these two into meters because anyways it will get converted cut. या तो फिर आपको कन्वर्ट करना हो तो यहाँ पर कन्वर्ट भी कर सकते हो अगर दोनों अलग अलग यूनिट में है तो ये 10 रेज़ टू माइनस 2 है वो तो कट ही हो जाएगा. तो आंसर जो है वो इसका आएगा 1.2 इंटू 10 रेज़ टू माइनस 10 फैरेड. ये एक आंसर आया. अब इसमें आगे पूछा है कि व्हाट इज द पोटेंशियल, डिटरमाइन द कैपेसिटेंस एंड पोटेंशियल ऑन द इनर सिलेंडर. तो पोटेंशियल C इक्वल्स टू Q बाई V. सो V इक्वल्स टू पोटेंशियल V equals to Q by C. We have written small q. So Q 3.5 into 10 raised to minus 6. C we have calculated 1.2 into 10 raised to minus 10. So the answer will be 2.9 into 10 raised to 4 volt. Question number 2.33 which says a parallel plate capacitor is to be designed with a voltage rating 1 kilovolt using a material of dielectric constant 3 and dielectric strength about 10 raised to 7 volt per meter. For safety, we should like the field never exceeds say 10% of the electric strength. What is minimum area of the plates is required to have capacitance of 50 picofarad. So we have to find out what is the required area for such a capacitor. So for parallel plate capacitor, C equals to epsilon 0 A upon D. Now this is filled up with some material having dielectric constant equals to 3. So we should write epsilon and it will be K epsilon 0 A upon D. Therefore A equals to C into D by K epsilon 0. C, K and epsilon 0 we know, but D we do not know. So how would we find out D? For finding out D, we have V equals to ED, this formula. So D equals to V upon E. E equals to 10% of E max, that means 10 by 100 into 10 raised to 7. That means 10 raised to 6 volt per meter. So now E will be 10 raised to 6 and V is 10 raised to 3. So D will be 10 raised to minus 3 meter. Now substituting all the values, A equals to C is 50 picofarad, 50 into 10 raised to minus 12. D has come as 10 raised to minus 3 divided by K is given as 3 and epsilon 0 is 8.85 into 10 raised to minus 12. So A comes as 18.8 into 10 raised to minus 4 meter square. So this is the area required for the capacitor's plate. Question number 2.34 which says describe the schematically the equipotential surfaces corresponding to a constant electric field in the Z direction. So equipotential surfaces should be drawn in such a manner that they are perpendicular, always perpendicular to the electric field. इलेक्ट्रिक फील्ड से वो परपेंडिकुलर ही होना चाहिए. तो z डायरेक्शन के अंदर अगर इलेक्ट्रिक फील्ड दिया तो उसके परपेंडिकुलर होना चाहिए. उसके परपेंडिकुलर मतलब यहाँ पर कौन से प्लेन के अंदर आएगा? इन xy प्लेन में ही आएगा. और ये यूनिफॉर्म है इलेक्ट्रिक फील्ड, इसलिए ये सब एक दूसरे से इक्वल डिस्टेंस पे होंगे, इक्विडिस्टेंट होंगे सारे जो है इक्विपोटेंशियल सरफेसेस वो सब. तो ये फर्स्ट का आंसर हो गया. सेकंड के अंदर पूछा है कि z डायरेक्शन के अंदर बट फिर ग्रेजुअली z डायरेक्शन के अंदर इंक्रीज होता हो वैसे. तो एज द इलेक्ट्रिक फील्ड इंटेंसिटी इंक्रीजेस उनके बीच का डिस्टेंस जो है वो नैरो नैरो होता जाएगा, बराबर. बट z डायरेक्शन में है इसलिए वो xy प्लेन के अंदर ही आएंगे. तो यहाँ पर भी लिखेंगे हम लोग इन xy प्लेन और इन z डायरेक्शन डिस्टेंस बिटवीन इक्विपोटेंशियल सरफेसेस डिक्रीजेस. ठीक है, तो ये हो गया उसका रिप्रेजेंटेशन. फिर थर्ड के अंदर सी में पूछा है कि सिंगल पॉइंट चार्ज है उससे कैसे फाइंड कर सकते हैं, उससे कैसे ड्रॉ कर सकते हैं. तो सपोज कि ये पॉजिटिव चार्ज यहाँ पर लिया है. पॉजिटिव चार्ज से कोई भी एक पर्टिकुलर डिस्टेंस पे मतलब उसको सेंटर कंसीडर करके उसके अराउंड कोई एक रेडियस पे कोई एक हम लोग स्फीयर कंसीडर कर ले तो वो एक इक्विपोटेंशियल सरफेस बन जाएगी. फिर अनदर रेडियस पे दूसरी इक्विपोटेंशियल सरफेस. तो ऐसे कंसंट्रिक स्फीयर्स के फॉर्म में होंगी ये. कंसंट्रिक spheres with charge situated at its center. ऐसे अगर सेंटर के ऊपर चार्ज को कंसीडर किया फिर कंसंट्रिक स्फीयर्स कंसीडर करे तो ये सब इक्विपोटेंशियल सरफेस आ गई. और लास्ट जो है उसके अंदर पूछा है कि अगर एक नेट है तो मैश अगर ली है वायर मैश तो उसके थ्रू इलेक्ट्रिक फील्ड कैसा होगा. तो उसमें दो चीजें हो सकती है कि जो क्लोजर पार्ट है, क्लोजर जो मैश है उसके नियरर, तो उसमें पोटेंशियल सरफेसेस इक्विपोटेंशियल सरफेसेस कुछ ऐसी दिखेगी वेवी. बट जैसे जैसे दूर जाते जाओगे वैसे वो एक दूसरे से ऐसे स्ट्रेट जो ये लाइन ड्रॉ की ना वो एक्चुअली ऐसे प्लेन है परपेंडिकुलर टू द प्लेन ऑफ दिस बोर्ड, उससे परपेंडिकुलर ऐसी आएगी. तो ये नियरर रीजन के अंदर और ये फार्दर रीजन के अंदर ऐसे इक्विपोटेंशियल सरफेसेस ये जो हैं वो मिलेगी.
Question number 2.35 it says a small sphere of radius r1 and charge q1 is enclosed by a spherical shell of radius r2 and charge q2. Show that if q1 is positive charge will necessarily flow from the sphere to the shell when two are connected by wire no matter what the charge q2 on shell is. बराबर. तो q2 के ऊपर ये q2 कोई भी हो चार्ज जो भी होगा बट q1 इससे सेकेंड शेल के ऊपर वो शेल के ऊपर स्फीयर से शेल के ऊपर ही जाएगा, ये हमें प्रूव करना है. ये कब पॉसिबल है? जब ये स्फीयर जो है वो हायर पोटेंशियल पे एंड शेल जो है वो लोअर पोटेंशियल पे होगा. तो मतलब कि इनका अगर डिफरेंस लेते हैं Vr1 एंड Vr2 देन इट शुड कम एज अ पॉजिटिव टर्म. तो हमें ये डिफरेंस फाइंड करना है और उसको हम लोग पॉजिटिव जो है वो शो कर देंगे. तो सबसे पहले Vr1 फाइंड कर लेते हैं. तो पोटेंशियल ऑन द स्फीयर Vr1 इक्वल्स टू K Q1 बाय R1, इसकी वजह से पोटेंशियल प्लस इसकी वजह से पोटेंशियल उसमें आएगा K Q2 बाय स्फीयर से बाहर है तो आउटसाइड के लिए K Q2 बाय R2 लिखते हैं. नाउ Vr2 इक्वल्स टू K Q1 बाय कितने डिस्टेंस पे? R2 डिस्टेंस पे और Q2 कितने डिस्टेंस पे, R2 डिस्टेंस पे। सो VR1 माइनस VR2 इक्वल्स टू K Q1 बाय R1 प्लस Q2 बाय R2 माइनस Q1 बाय R2 माइनस Q2 बाय R2। Q1 बाय R2 Q2 बाय R2 ये कैंसिल हो जाएंगे टर्म, हमारे पास क्या बचा K। फिर Q1 जो है उसको कॉमन ले लेते हैं, 1 अपॉन R1 माइनस 1 अपॉन R2। तो इसमें Q1 तो पॉजिटिव चार्ज है, 1 अपॉन, अगर इसको ये पॉजिटिव है, ये अगर हम लोग प्रूव कर दे तो ये भी पॉजिटिव आ जाएगा। नाउ वी नो दैट R1 इज लेस देन R2, R1 रेडियस कम है R2 से, तो 1 अपॉन R1 कर दूं तो वो ग्रेटर हो जाएगा। तो ऑब्वियसली 1 अपॉन R1 माइनस 1 अपॉन R2 विल बी ग्रेटर देन 0। तो ये ग्रेटर देन 0 आया, Q1 पॉजिटिव है एंड Q1 इक्वल्स टू पॉजिटिव चार्ज। तो VR1 therefore VR1 minus VR2 will also be greater than 0. So as the sphere is at higher potential than the shell, the charge Q1 will flow from sphere to shell। और इसके अंदर जो हम लोगों ने डिराइव किया उसमें Q2 का कोई भी रोल नहीं है, तो Q2 क्या होगा उसके ऊपर ये डिपेंड करेगा नहीं।
Question number 2.36 which says the top of atmosphere is at about 400 kilovolt with respect to the surface of earth, corresponding to an electric field that decreases with altitude. Near the surface of earth the field is about 100 volt per meter. So why then do we not get any electric shock as we step out of our house in the open? तो यहाँ पर क्या होगा कि हम लोग बाहर जब निकलते हैं तब अर्थ के कांटेक्ट में होंगे, then at that time our body and the earth as they are in contact they form and they both are at some equipotential surface. Body and the earth they combine, they together they will form an equipotential surface. So equipotential surface के ऊपर तो चार्ज जो है वो फ्लो हो सकता नहीं है, इसलिए चार्ज जो है वो फ्लो नहीं होगा, तो कोई शॉक लगने की जो है वो पॉसिबिलिटी नहीं है। Then B, a man fixes outside his house one evening a 2 meter high insulating slab carrying on its top a large aluminum sheet of area 1 meter square. Will he get an electric shock if he touches the metal sheet next morning? तो रूफ के ऊपर कुछ इंसुलेटिंग मटेरियल और उसके ऊपर कंडक्टिंग मटेरियल एल्यूमिनियम रख दिया। नाउ पूरे दिन के दौरान क्या होगा कि जो भी लाइटनिंग है अर्थ के अंदर जो भी चार्ज डिस्चार्ज हो रहा है दैट विल गेट एक्यूमुलेटेड ऑन द शीट ऑफ एल्यूमिनियम। सो एंड उसके नीचे का लेयर जो है वो इंसुलेटेड है। सो आफ्टर वन नाइट इज ओवर, तो दूसरे दिन जब वो उसको टच करेगा, नेक्स्ट मॉर्निंग व्हेन ही टचेस द ड्यू टू द चार्ज एक्यूमुलेटेड ऑन द aluminum sheet, he will definitely get a shock, electric shock. C, the discharging current in the atmosphere due to the small conductivity of air is known to be 1800 ampere on an average over the globe. Why then does the atmosphere not discharge itself completely in due course and become electrically neutral? In other words, what keeps the atmosphere charged? तो एटमॉस्फेयर के अंदर से डिस्चार्जिंग तो काफ़ी होता रहता है कंटिन्यूसली, फिर न्यू चार्ज जो है वो कहाँ से आता है? तो स्मॉल लेवल के ऊपर थोड़ा थोड़ा कंटिन्यूसली हमेशा जो चार्जिंग है वो लाइटनिंग और थंडरस्टॉर्म के थ्रू मिलता रहता है। तो जो भी कम हो जाता है चार्ज वो अगेन वापस से उसको मिल भी जाता है। तो दिस इज हाउ द चार्जिंग ऑफ एटमॉस्फेयर हैपन्स। देन द नेक्स्ट वन, what are the forms of energy into which the electrical energy of the atmosphere is dissipated during a lightning. तो लाइटनिंग में एक तो लाइट एनर्जी जो है वो दिखती है, फिर लाइटनिंग का साउंड आता है, एज वेल एज हीट इज ऑल्सो जनरेटेड. तो जो भी इलेक्ट्रिकल एनर्जी है दैट गेट्स कन्वर्टेड इनटू हीट एनर्जी, लाइट एनर्जी एंड साउंड एनर्जी.